So far, all of our programs have only printed out static text. Text that is always the same thing every time we start the program. Well, programs wouldn't be very useful if they could only print out the same thing every single time. For example, if a calculator could only tell you what 2 plus 2 was. A computer works with data. And data is any piece of information that you can think of, and data can also change. So, for example, your age is a piece of data, but your age also changes every single time you get older. And your address is a piece of data that changes less, but it changes whenever you move. Variables are what we use to represent data. Data is stored in a computer's memory so that the computer can access it. Variables let us access this data and let us represent it. Naming variables in C is a very important process, and all variables in C have a name. It's how you know which piece of data you are using. Naming variables does have some restrictions. Variable names can only have numbers, letters, and underscores, and no special characters. They also cannot start with a number. They can have numbers within the name, but they just can't start with them. They also should be descriptive. While it won't cause your program to break, it does make it a lot easier to read. A variable A or B is a lot harder to understand what it is in context than a variable such as age. Variables in C also have types, and the types are very important because you must choose the type of variable you want to use before you start using it. The most common type is the integer. It's written just as int. It contains data like 1, 5, 4, 5,403. It only contains whole numbers. No decimal places can be used. It cannot store numbers such as 2.5 or numbers such as 5.2. Another type of variable in C is the char, or the character. It allows you to store single characters in memory, such as A, B, or F. Notice how there is also numbers inside of our characters, but these aren't numbers like integers. They are the character of the number. The last two types of variables are the double and the float. They both store numbers, but they store numbers with decimal points, such as 4.3 or 796.3. The only difference between them is double is more precise than float. It allows you to have more decimal places. The number of decimal places and the precision does change from PC to PC. For the most part, you should use double because it is the most safe, and unless you're really worried about conserving memory, it's not much of an issue to use a double. Let's take a look at how variables are used within code. If I know I want to store some data so that I can use it, such as an age, I have to declare a variable. I have to say that I want to use a variable named this of the type that. If I want to declare a variable that holds an age, then I have to declare it. So to do this, I start with the type. I write the type of variable. An age is a whole number, so that means we want to use the integer type. So we start by writing int. Once we've written int, we come up with our name, and because we want to store an age, it's probably best to name this age. So we write int age, then semicolon. We're done. We've declared our variable. Now that we have our variable, we can start storing things in that. To do this in C, you write age equals 5, which means equals is the assignment operator. It assigns 5 to age. So now age is storing 5. If I wanted to store a price which has decimal points, then I know I should write double price. Then I know that I've created a variable called price which can store numbers with decimal points. Then if I want to assign it, I do it the same way. I say price is equal to 20.5. Now, if I know right away when I'm declaring it what I want it to be assigned, I can actually merge these two lines and make it double price is equal to 20.5. So this declares a variable price, and sets it equal to 20.5 right away. The last type I'm going to cover is the character, and this is an example of using the character. We created a variable called the first initial variable, and it stores my first initial, which happens to be capital R. Notice how R is within single quotes. This tells the compiler that it's a character. So now capital R is stored within first initial. Now remember, when you are naming your variables, you have to use valid names. Here are some examples of invalid names. This name would not work because it has a space in it, and it would confuse the compiler. Same with this and this, because these both have special characters within the name. Also, this would not work because it starts with a number. But you do have some freedom in naming. All of these would work using the underscore to separate the words, or placing a 2 after it would work perfectly fine. Variables are basically useless unless you can output them and let the user know what's inside of them, or at least use them in some way. The printf function allows you to include variables in its output so that you can output the data stored within the variable. So if I have the variable age and I want to print out the contents of what is stored at age, which happens to be 5 in this case, after age colon in the printf, there's a few things we have to do. First, you have to figure out where you want to print out the variable, where the 5 is supposed to actually appear. And we know that we want it to be right after age. So we need to put a placeholder inside our printf statement so that printf knows that there's supposed to be a variable there. So to do this, we make a bit more space and we put our placeholder. Now this is a placeholder for an integer. The percentage sign tells printf that something special is here. And whenever it gets a percentage sign, it's going to look to the characters right after it to ask it what type is after it. Each variable type has a corresponding format specifier for the printf statement. So as you can see, percentage sign $d is the integer, and it's the decimal. Even though there's no decimals in integer, that's still how it is. Percentage sign $d is the integer placeholder. Percentage sign $c lets us print out characters, so like A, B, or C. If we had a char, then we could print out the character using percentage sign $c. Then we have our float, which is percentage sign $f, which makes a lot of sense because F float. Then we have double, which is LF, which actually means long float, because technically a double is a long float, which means it's a float, but it has more space into it because it's more precise. So those are the placeholders you have to use to tell printf that they're supposed to be a variable. Now that we've told printf that there's supposed to be a variable printed out there, we actually have to tell printf what to print out. Which variable are we printing out? And we do this by creating a bit more space and putting comma age. So we write after the quote, we write comma, which says we're giving it another piece of information, and age. So it takes the value of age, places it out, and so when you actually run this printf statement, you'll get age 5. Now what happens if we have multiple placeholders like in this example? Well, it follows the order of the placeholders. So in this example, this will print out 8 drinks at $2.13. When printf is processing the output, it will first look for the first placeholder, which happens to be the percentage sign $d. It automatically uses the first variable given. Once it moves on to the second placeholder, it will know to use the second variable. The order is what determines which variable goes where. So you need to give your variables to the printf statement in the same order that you want them to be printed out in. So here's a quick example of everything we've learned so far in this video. We have a simple program that has a bunch of variables declared and then printed out below. So if I run this program, you'll see the contents of all of these variables being printed out. And so if I change any of these values, the printout will also be changed as well.